We're in our second unit here, the periodic table and atomic structure. We're in the second lesson titled the periodic table. Our objective for this lesson is that students will be able to determine how many protons, neutrons, and electrons an element has by looking at the periodic table. Before we jump into answering our objective right away, I want to pay homage to the father of the modern periodic table, Dmitri Mendeleev, who said this quote: "It is the function of science to discover the existence of a general reign of order in nature and to find the causes governing this order. And this refers in equal measure to the relations of man, social and political, and to the entire universe as a whole." Now, what Mendeleev was saying here was that he craved an understanding for order within our world, and he knew that that meant understanding the elements, what they are, and how they're organized, how they're related to each other. So he basically devoted himself to trying to figure this out. So the first document you can see here is a primary log of research that he had on different elements. So here are the different elements that he knew of, and here was some data he collected on them: melting point, boiling point, density, and he even knew some of the configurations of the elements, which we're actually going to talk about later. So that was some initial work he did with elements. The next two documents here are a sort of rough periodic table. He was attempting to organize the elements and see how they're related to one another. So you can see the first element, hydrogen, lithium, all the symbols here. The numbers here were their atomic weight. So you can see here it kind of lacks, it has some organization, but also lacks what we know to be the common periodic table. So I'm going to bring up this last one here, which is a bit more organized. You might notice that he started to put group numbers here, which means there's probably something similar about the elements in the same column and maybe the same row. The beauty of Mendeleev's periodic table, the most powerful function, is that he left blanks. Now, why is that so amazing? Because he was so confident in how he organized his elements that he said, I bet we're going to discover an element that fits right here, based on these patterns that I see. And he ended up being right, which is why he got credit with being the father of the periodic table, because his tool was such a powerful predictor of what was to come. So we're going to jump into our objective here today, and you are going to learn how to determine how many subatomic particles each element has. Now, when I say subatomic particle, you need to know that I'm saying electrons, protons, and neutrons. There are 3 of them. So the first one we're going to talk about is protons, because it arguably is the easiest. So I'm going to zoom in here on this periodic table, which you will always have access to on any quiz or test. So we want to be very familiar with how to read it because it's a great tool for us. So if I'm talking about hydrogen here, where I can see the name and the symbol, I see this whole number here. The whole number 1 is called its atomic number. Now that is a vocabulary term, so I'm going to bring this in here and make it nice and big. And you should go ahead and write this down because it's an important definition. Atomic number is the number of protons that an element contains. Go ahead and write that down. Pause me if you need to. So if I know that simple definition, then I can look at the periodic table and say pretty quickly that hydrogen has 1 proton. Lithium has 3 protons because its atomic number is 3. Beryllium has 4 protons because its atomic number is 4. Now, if I zoom out here and look at the periodic table as a whole, you're going to notice a really interesting pattern here, which is that the atomic number increases as you move across a row and then back down. So there is a real trend here for the periodic table in terms of protons. In fact, there is such a pattern here that we actually can say that the periodic table is organized according to atomic number. That is a key point. The last important point about protons and atomic number is that they literally give the identity of an element. So what do I mean by that? Well, if I were to ask you what makes you you, or what makes you different from somebody else, hopefully from last year in biology, you would tell me that what makes you you is your DNA, right? If you change your DNA, you literally change who you are, what you look like, how you act, how you think. So your DNA gives you your identity. If I were to ask you what gives an element its identity, you should now tell me its atomic number. If I were to change how many protons hydrogen has, and I gave it another proton, I would literally turn it into helium. If I gave helium another proton, I could turn it into lithium. So by changing the atomic number, I change the identity and all the properties, what it looks like, how it acts, just as I would change you if I changed your DNA. The next subatomic particle we're going to talk about is the negative electron. Now, the first thing that you need to know to figure out how many electrons an element has is you actually need to be familiar with this definition. So go ahead and write this down. Neutral means no overall charge due to a similar number of positive protons and negative electrons. Now, positives and negatives are opposite charges, so they cancel each other out. So if you have 5 pluses and 5 negatives, that would be neutral because there's no overall charge. So all the elements, as you see them on the periodic table, are neutral. So how does that help us? Well, if I go ahead and zoom in here on the periodic table, I know from my last slide that helium has 2 protons. And I know that helium is neutral. So if I know it has 2 protons, then it must also have 2 electrons to be neutral. It is that simple. Let's do another example. Boron. Boron has 5 protons and therefore must have 5 electrons to be neutral. Carbon, 6 protons, 6 electrons, 7 protons, 7 electrons. Seriously, it is that simple. Now, I do want to mention if you're a little confused right now because you remember from somewhere in the past life or last year or whatever, you remember talking about how sometimes protons and electrons can be different. You are correct, and you're thinking about ions, but we're going to hold off on talking about ions because they're not neutral. So don't worry about it right now, but I just want to sort of calm your fears if you were worried that you just didn't learn anything last year in chemistry for right now. The last subatomic particle we're going to talk about is the neutron. Neutrons are neutral, and they're located inside the nucleus, and we have to do a little bit of work to figure out how many neutrons an element has, because it's not directly listed on the periodic table like it was for protons and electrons. So the first piece of information that's helpful when figuring out neutrons is this definition: mass number. Mass number is the number of protons plus the number of neutrons. So now I'm going to zoom in to show you where to find the mass number. You find the mass number by taking this decimal number and rounding to the nearest whole. So this would be rounded to 39, this would be rounded to 40, 45, 48, 51, etc. If you have any questions about rounding and whether you round up or down, ask a friend or come ask me. So how does the mass number help us figure out how many neutrons we have? Well, let me do an example and I'll show you. So let's do potassium here. I know that the mass number of potassium rounds to 39. So potassium has a mass number of 39, which means if I were to add up its protons to its neutrons, I would have 39 particles. Now, 39 particles, and I know that 19 of those are protons, right? We just learned that. 19 of those are protons. So basic math tells me if I have 39 things and 19 of them are protons, that must mean that the rest, those other 20 I get by subtracting, must be my neutrons. That's not too bad, right? Not too bad math. So what you have here is the mass number minus the atomic number will give you neutrons. All right, let's do an example here to see if you understand. Let's pick iron. So I'm going to make it nice and big here for you. Here's iron. The symbol is Fe because of its Latin name. Doesn't sound like iron, right? So go ahead and see if you can figure out how many neutrons iron has. Now pause me if you need to because I'm going to give you the answer. So the answer here is that there are 55.8. So I round that to the nearest whole. 56, which makes sense, right? Because you can't have part of a proton or part of a neutron. We'll talk later about where they get that decimal number from. But I have 56 protons and neutrons. And I want to subtract away the protons, which is its atomic number. And I'm going to get 30 neutrons. So hopefully you said 30 for that. All right, well, this wraps up this lesson on being able to identify the subatomic particles of any element on the periodic table. And I hope you had fun. Before you go ahead and turn me off, I want to make sure that you got out of the video what you were supposed to get. So can you define atomic number, neutral, and mass number? Can you identify the atomic number and mass number of any element? Can you identify the subatomic particle that gives the element its identity? And then finally, can you identify how many protons, electrons, and neutrons any element has? If your answer to any of these is no, I would go back and rewatch the video with that particular task in mind. If you find where it is on the video, but you have a clarifying question, go ahead and write the question down and bring it into class tomorrow. If you come into class and just say, oh, I didn't understand anything, I can't really help you because I don't know what you don't understand. So try to be as specific as possible when you come in with questions.